Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject short range wireless communication. We're going to see the second video in baseband coding, where we're going to see dominant criteria for baseband coding selection. In previous video, we have seen various formats about baseband coding. What is baseband coding? What are the different formats? And today we're going to see what are the important criteria for selection of this baseband coding, right? And to start with, we already know what is baseband coding. Uh, Baseband coding is a form of an information signal that is modulated onto the RF carrier. We can also call this baseband coding as line coding. Line coding. To make it in a very simple term, this baseband coding is where we convert a binary data into a binary signal. That is, we know what is binary data. Binary data is 0 and 1, right? Say, for example, if this is our data, converting this binary data into a signal, into a binary signal, that is called as line coding, like this, right? So this is 0, this is 1, 1, 0. So it is a form of converting a binary data into a digital signal, right? And we have different formats of baseband coding. That is for the representation of digital signal can be of different forms, which we have seen in previous video, right? We have seen what is NRZ format, Manchester coding. We have seen biphase level. We have different forms of representation of this particular baseband coding. And with this number of baseband coding techniques, uh, we can able to select a particular coding technique for a particular application depending upon certain criteria, certain characteristics. That is called as dominant criteria for choosing the baseband coding, right? And as I said, every message, right? Every message will have its own fields. That is, you have a data field, you will have an address field, where in address field you will have information regarding source address, destination address, and then you'll have the original data, and then you'll have bits to correct errors. Like that, if you take any particular message, you'll have a lot of fields like address fields, data fields, and everything, right? The information which is need to be transmitted, right? First, we have to convert that into a signal level, right? And only if we convert it to a signal level, it can be received and decoded properly, right? And that is why line coding is very important, right? And as I said, we can also say that it is an essential way of converting zeros and ones into a digital form, right? Now, coming to criterias, these are the very important criterias for selection of baseband coding. That is, even though we have a lot of different techniques, each and every technique has its own advantage and disadvantage. And depending upon the application, we can choose any particular coding, right? And these are the important criteria, which is timing, DC component, power spectrum, inherent error detection, probability of error, and polarity independence, right? And I already said what is data level and what is signal level, right? Data level, say for example, if I am taking the same example here, if we say this is a binary data 0, 1, 1, 0, the data level here is only 2. That is a binary data. So the data level is 2, right? And what is signal level? Say for example, if I'm going to represent this particular data like this, like this. For 0, there is uh, minus voltage, minus A, and this is plus A. And for 1, there is plus voltage, and for 0, it's minus voltage. Now, coming to signal level here, the signal level is 2. The signal level is 2. And the data level is 2. The data level is 2 because it is a binary data, 0 and 1 only. And here, the amplitude is only 2. That is, it is either A or minus A. There is also other different formats where, say for example, if we have a format like this, right? 0, 1, and another. Say for example, if this is 1, and this is 1, and this is 0. And now here, you can see there is 3 signal levels. There is 0 and you have A and you have minus A, right? You have 0, A and minus A. So signal level is 3 here, right? So you have now you understand what is data level and signal level, and depending upon this data level, signal level, you have other criteria as well. As I said, timing, DC component, power spectrum, everything varies with respect to the coding which we use, right? And what is timing? Timing is very important for any line coding technique. Synchronization is very important, right? That is, whatever bit transmission that is happening in the transmitting side, that is the bit intervals at the transmitting side, must exactly synchronize with the uh, bit interval in the receiving side. Say for example, if your bit interval is like this in the transmitting side, even on the receiving side, it has to be in the same form. That is, it has to receive synchronously. If it is out of synchronization, we will not be able to receive the error data properly. We will not be able to decode it properly. And at the receiving side, the receiver has to receive the message along with the noise, right? So it is very important. Timing is very important, and the decoding ability depends upon the proper timing, right? And another important thing is DC component. So what is DC component? DC component refers to the average voltage level, right? And for any line coding, right, if we say there is no error, then there should be zero DC component, right? Any particular line coding which we use, it can be NRZ, Manchester, or any coding which we use, the DC component has to be zero, right? A non-zero DC component means there are chances of error, right? So what is that DC component? It has to maintain zero DC component. Say for example, if you take this particular waveform, I just for an example I'm telling. Okay, so in this waveform, if you see, right, we have a negative voltage, positive voltage, negative voltage, positive voltage, correct? So here the positive voltage and negative voltage are getting cancelled each other, right? So the average DC value will be zero. The average value will be zero. So that is, does not have any DC component, right? And here the chances of error will be very less, right? There is no distortion. And say for example, there are other DC component, other line coding technique where you will have like this, right? For 0 there will not be any values, and for 1 you will have like this. And if you take this as an example, you have right now the average value will be, you'll have an average DC value. This is the average DC value because there is no negative values here, so the positive voltage will not get cancel each other, right? So now what happens? You have a DC component, and coding with this form, with this particular format, is prone to errors. We will have errors. There are a lot of distortions is possible, right? This is known as DC component. And what is power spectrum, right? You have the frequency response of different coding techniques is completely different, right? And we should have a narrow response. We should have a narrow response so that we can able to have minimum error. That is, it can able to filter the errors if the response is very narrow. And inherent error detection. This is very important criteria. What is inherent error detection? The coding itself, right? Depending upon the transition, right? And you have each and rules and regulation, right? I would recommend you people to go and watch the previous video before seeing this video so that you can understand the basics of line coding, right? So what is error detection here? Inherent error detection, the coding, the baseband coding which we use, the format must have itself an inherent error detection technique. What is inherent error detection technique? Right? We know that there should be a transition. Like if you take Manchester coding, you will have a transition for 1 from positive to negative, and for 0 you have from 0 to positive. Like this, you have transition, right? And this varies depending upon various formats, right? And whenever there is a change in the transition at the receiving side, right? After receiving it, the code must have the error detection capability itself. That is, depending upon the transition or depending upon other characteristics of that particular baseband coding, you should be able to detect error. That it should understand that there is an error. Say, for example, if it is 1, it has to start from positive to negative. And if it is from 0 to 1, right, then the receiver should understand that there is some error, right? And say, for example, you have another coding technique where in biphase level, you will have transition at every bit, like every bit. So here, if you say in this particular biphase level, you have a good error detection technique. That's because every bit will have a transition at the beginning. So at the receiver, while receiving a signal, if there is no transition happening at the change of bit, then it has understood that there is some error. So it will neglect that one, right? That is called as inherent error detection technique, right? The baseband coding must itself have this error detection capability. And what is probability of error? Probability of error is completely different from inherent error detection. Inherent error detection speaks about the error detection capability, whereas probability of error is the quality of that particular baseband signal, right? It should have lesser probability of error, right? The probability of error occurrence must be very less, right? And so that the quality will be good. That is called as probability of error. And polarity independence. So what is polarity independence? Right? It is a very important criteria, important parameter, right? Where even if the code is inverted, right, it should maintain its characteristics. But in most of the cases, that is not possible. But there are some coding techniques, right, which we saw earlier, which has this particular property, polarity independence. Even if the polarity changes, right, the characteristic will remain same, right? So all these are dominant characteristics of baseband coding, and based upon this characteristics, we can choose the baseband coding or line coding, right? And we will see this one by one. For example, timing. As I said, timing, the receiver must be able to receive the polluted noise signal, and it should be able to recognize the transition of each bit, right? And that is the transition which is happening at the beginning of the bit and in the middle of the bit. Everything has to be detected perfectly, even though if there is a continuous string of ones or zeros, right? That is, the receiver should not be taken away because of the message content, right? If there is complete zeros, or continuous ones, then it should not uh, decode the message wrongly, right? That is, the bit transition must be independent of the message, right? If the message has zeros continuously, if it has ones continuously, then it should not affect the decoding process, right? And the bit transition should be independent of this particular message content. And what is DC component? As I said, DC, the average DC content must be 0. The average level, that is called as a DC level, and this level has to be constant throughout the message frame, right? And to be frank, we should have 0 DC content. That is, the positive and negative voltage has to get cancel each other, right? If not, if there is non-zero DC component, then that particular baseband coding have chances of getting distorted, right? And coming to power spectrum, uh, each and every baseband coding system have different frequency responses, and a good narrow frequency response can filter more effectively to reduce the noise, right? So that is about power spectrum. And I already said what is inherent error detection capability. That is, the code should allow the receiver to recognize an error on a bit by bit basis, right? Having a low possibility of reporting a false alarm when the error detecting bits are not used, right? That is, as I said before, the coding techniques must have its own error detection technique, bit by bit basis. It should detect the error, right? And it should by detecting the error, we can able to avoid the false alarm conditions, right? And what is probability of error? Ability of properly decoding a signal, right? So the probability of error has to be very low in any particular baseband coding so that the quality will be good. And what is polarity independence? As I said, there is some advantage. Uh, you have some codes which retain its characteristics even if the polarity is inverted, right? And there are some modulation or demodulation techniques which does not support the polarity independence. For example, phase modulation, right? These are some very important dominant criteria which is used to select the various different line coding techniques. And depending upon the applications, we will choose different coding techniques, and depending upon the characteristics, right? whenever you need a better noise immunity or whenever you need better DC level, a corresponding line coding will be decided or it can be used, right? And today what we have seen is we have seen a very important concept in short-range wireless communication. That is, we have seen the characteristics, dominant characteristics of line coding, right? I believe this video will be useful for you. Thank you, my dear students.